Hi guys, I want to make a short educational video about tower fires or skyscraper fires. See, there's a special category of fire for different types of circumstances. For example, you have industrial estate fires where the typical issues are you got many sources of fire such as welders and cutters and all sorts of things that generate sparks and heavy machinery and oils, and you have combustible materials stored in large quantity, flammable materials. You may have, in some types of factories, you may have explosive materials. So there is a typical thing that causes fire, and you need to look at all those things in industrial estates. On the other hand, let us look at slums, for example. So slums don't have the same type of features as skyscrapers, but slum fires are caused by very small passages, houses cramped close together, electrical cabling done very badly, cheap cabling material, overcrowded spaces with lots of combustible material lying around, illegal connections from meters leading to sparks and stuff like that. So these are the special circumstances that cause fires in slums. And the challenges in fighting those fires are also because of some circumstances such as inaccessible narrow pathways between houses, so that fire brigade can't even get to the parts where the slums are on fire. These are some of these challenges. There may be fallen structures like metal balconies falling into these narrow passages, making it difficult for firemen to go there. These are some challenges that happen in slum fires. In the same way, there are some challenges that you have to look at, and some special causes that you have to look at, special circumstances in skyscraper fires, tall structure fires. So let us look at what happens in tall structure fires and what is the kind of safety measures to be taken, and what are the ways in which things can play out if those safety measures are not taken. In tall structures or skyscrapers, we can call them towers, we can call them skyscrapers. Nowadays it's fashionable to call them towers. So in towers, the main issue is that you have living spaces, flats, stacked one on top of the other. Okay, large number of flats stacked one on top of the other, so that if there is a fire in the lower flat, that fire tends to move upwards because of simple flames moving upwards. Now this is the most basic level at which you look at a tower fire, the tendency of flame to move upwards. You know how we have this this triangle, this pyramidical structure that we make for burning holy wood. The reason we do that is you can light a bit of straw at the bottom, and then you make wood stand up in a tall tower like structure, and the straw at the bottom which burns will ignite the wood which is harder to burn, and then within a few minutes you have the whole thing catching fire when the ignition temperature of the wood is reached. The ignition temperature of straw or oils or volatile materials like kerosene is typically very low. It requires very little temperature. A small flame can light kerosene on fire. a small flame can light straw on fire, and then that straw lights something with a higher ignition temperature, like wood, for example. It may even be treated woods and things like plywood, and then it may be fire resistant up to a certain extent. But after a certain temperature is reached, even something which appears to be fire resistant starts burning. Or after a certain amount of time, after a certain amount of exposure to fire, the fire resistant properties of that material are overcome, so to speak, are defeated by the fire itself, and then the material ignites. And then you have that material not only burning but also emitting fumes, okay, of poisonous material, poisonous gases, which come from actually the stuff that is supposed to suppress fire. Okay, the fire suppressant chemicals may themselves turn may emit very toxic fumes. So you have this kind of situations. Now let's talk about the tower exactly, a skyscraper. In a skyscraper, you have houses stacked one on top of the other. Within an individual house or an individual room, there is always a possibility of somewhere, some house getting into a small fire situation. That situation can come from a carelessly placed cigarette. A cigarette placed close to a newspaper, for example. A few sparks falling on the newspaper on a wooden table on a carpet on a wooden floor, bed, mattress lying on that wooden floor, okay, a sofa which is made of, let us say, combustible fabrics, curtain in that room may be combustible. Okay, this kind of a transmission within a room can happen anywhere in any tower, and eventually, given the number of houses there are in any tower, it is almost certain to happen. It is only a statistical thing how long it takes to happen. It can happen in a kitchen. For example, let us say frying pan in a kitchen overheats and the contents start burning. Okay, careless housewife puts stuff in the in oil that starts burning, shallow frying, and it starts burning. Let us say she is a careless and ignorant housewife. So when it starts burning, she panics and throws a pan of water at it. Now when you throw water at an oil fire, you know that it is going to sort of explosively rise up. It creates a column of fire. Let us say it ignites some wooden furniture in that kitchen, or oil splashes all over the place, and maybe there are some wooden tables, or there is oil lying near her stove that spills, spreads across, catches fire. Now you have a larger conflagration. You have a fire. Okay. So in this way, there are multiple sources, multiple possibilities of fire. It can be an electrical short circuit. It can be a welder working somewhere in the building. Okay, working carelessly, working without sufficient safety measures. All sorts of workmen working without imagination. Okay. These are some of the very simple situations which cause fire. So it is only a statistical thing. Given enough time, a fire is almost certain to happen in some house, some room, some corner of a tower. The question now is, what happens next? If it is a well-designed tower, that fire is contained within that space. It is contained within that room. The smoke may come out of the window, but the fire is not allowed to communicate with flammable materials elsewhere in this tower. Okay, it doesn't get a pathway to spread. This is called passive fire protection. It is also called containment. Containment means that you have things that will contain the fire within a small space and not allow it to spread. What is containment, and what kind of typical containment structures are there in a house? For example, a brick wall is a containment structure. It does not allow the fire to go outside. As long as the brick wall is there, it's a strong containment structure. A fire-rated door made of fire-resistant materials can also be a containment structure. So you just leave that room and slam the door, and the fire will not burn down that door for say 2 hours if it has a 2-hour containment. After which, yes, it can overwhelm. If the fire persists, then it can overwhelm the door and the door will start burning. But this is an example of containment. You have walls, you have doors. Now the ceiling, let us look at the ceilings. The ceilings are also containments because the flames are leaping upwards. If there are holes in the ceiling, that is, if there is a pathway for the fire to reach the flat above, then that is a breach of containment. There is a lack of containment. But instead, if there is a solid RCC slab between your house and between the house where the fire happened and the house upstairs, that is containment. It's very effective containment. Okay, RCC slab is a fantastic containment. And if the RCC slab has a chhajja going out, it means that when the flames come out of the window, those flames will not communicate directly with the flammable materials in the house upstairs. The flames will be some distance away from the other guy's house, and hopefully the other guys, the upstairs people, will remove their curtains and stuff like that when they see smoke happening, and hopefully the flame will not be able to catch any inflammable part of the house upstairs. This is how containment happens. And in the meanwhile, yes, you have various things that are called active measures and fire suppression measures. One of the fire suppression measures is sprinkler systems. If there is a fire in a house, sprinklers are activated. For sprinklers to activate, you have to have smoke detectors and heat detectors, which are actually, sprinklers will activate themselves when a bulb reaches a certain temperature. It's this little thingy inside the sprinkler. It will rupture and the sprinkler is activated. Now that is a fire suppression measure. Another fire suppression measure will be if there are let us say there is a fire extinguisher close at hand and people can spray the fire with fire extinguisher. That is also an effective active fire suppression measure. So after the passive measures such as brick walls and doors and ceilings and so on, come the active fire fighting measures. And then if all of this fails, by now someone has phoned the fire brigade, and the fire brigade comes in and brings in a lot more power. Okay, by then, if the fire has not been contained, then the fire brigade is needed to land up and use big fire engines, fire hoses, etc., etc. So if the fire has not been contained in the house, if it has spread, then the firemen need to do their thing. But as far as possible, for a medium-sized fire, it is always considered that the fire should be suppressed within and contained within a relatively small area. Now, I was talking about skyscraper fires. Let us talk about how things go wrong with skyscrapers and why you have skyscraper fires where fires engulf several houses, sometimes entire floors, sometimes many houses vertically, an entire, how shall we say, at a block or a wing of skyscraper, sometimes spreading to other wings also. How does this happen? This is, there have been fires like this. I'm not talking about unusual events. It happens, unfortunately, with regularity all over the world. It doesn't happen only in India, it happens all over the world. Skyscraper fires happen when the fire finds a fast track to spread. Without fast tracks, fires tend to stay in small areas. They tend to stay inside of a house, or they tend to stay inside of a room. Now, why will a fire inside a room turn into a horrible, life-threatening, massive disaster called a skyscraper fire, which takes out, 10 floors, 15 floors, 20 floors, and rages all night, sometimes rages for 48 hours, 72 hours, 96 hours. Firefighters go in there, struggle, some of them die. People cannot be evacuated. People jumping out of their flats from their balconies and falling down and dying. People being trapped in some areas and screaming for help and not being able to find help and ultimately succumbing to poisonous smoke and gases, heat. How does this sort of a horrible catastrophic scenario happen? This kind of scenarios happen when fire finds a track. What is a track? What is a track? A track is chimney type structures, first of all. If a building has an abundance of chimney type structures, or even one or two chimney type structures, which allows the fire in one flat to easily communicate with combustible materials in the flat above or in the flats above, then you have a fire which can spread extremely fast within minutes or even within seconds to higher floors. Now that is a bit like giving a railway train on a track. Think about a railway carriage without a track. The metal wheels on the ground. What happens if there is no track? You give it a push, it doesn't work, the metal wheels will just sink into the ground. Okay, it's not going to go forward. Take the same thing and give it a track. Put that carriage on a track and give it a shove. Now there is no resistance because this thing can move on a track. It is going to go very far and very fast. In the same way, a fire. What is the natural tendency of a fire? To go upward. Flames, hot gases. Where do they go? They go upwards. Partially combusted gases. Where do they go? They go upwards. If they have to go upwards, what would you want to do with a flame? You would want to send it away from the building. How would you send it away from the building? Well, if you have a window and the window has a chhaja, and the chhaja is, let us say, 1.5 feet long, Okay, then you would have the flame being kept at a distance of 1.5 feet and basically finding air outside the building but not inside. On the other hand, if there is a chimney like structure, what happens? Here's the physics. You have hot gases. Hot gases want to find a place to start rising. Okay, there is a tendency for it to look for places where it will communicate with low pressure region. Where is the low pressure region? Low pressure region is higher altitude. So if a house on the say 10th floor finds a chimney, a duct for example, which communicates with the 20th floor, then the house on the 20th floor has lower air pressure than the house on the 10th floor, and so these gases rush towards that chimney and rise into that chimney and rise into that higher house on the 20th floor, and on the 20th floor they start exiting. You got hot gases which start exiting, and not only on the 20th, from the 10th to the 11th and the 12th and the 13th and the all of them, they exit. These are partially combusted gases, very hot gases, 700, 800, 1000 degree centigrade gases. They find a material whose combustion point is lower, say 600 degrees, say 500 degrees, say 400 degrees centigrade, and that thing will combust, will ignite spontaneously. Okay, when this hot gas meets, let us say, paper. So what you have is, if this duct has been used and the duct is being used for storing let us say suitcases or raddi paper or cloth, different kinds of cloth, then the cloth, the paper, the combustible material will ignite. And when it ignites, now the fire on the 10th floor has started a fire on the 15th floor or the 20th floor. Now you have a double-barreled fire, and so on. So when you have any kind of a chimney type structure, you give fire a fast track. There is another thing that gives fire a fast track, that is wood, an abundance of wood. If the fire exiting a window or a balcony finds concrete, then it will not be able to propagate very well. It meets something that is not going to burn. But if that fire licking outside the window finds wood upstairs, communicates with the wooden floor upstairs, like the wooden floor of a balcony for example, okay, then that's going to start burning. And when that starts burning, it seeks other combustible material within the house and even outside the house, and it sends up flames, shooting up flames, and another set of combustible material, another set of wooden floors are found, and starts burning again. And that is how fire uses fuel, that is combustible materials, to spread. The moral of the story is this: skyscrapers have to be designed keeping in mind that there should not be chimney type structures, not only inside the houses but even near the houses. And as far as possible, the RCC slabs of houses should be without breaches. There should not be holes and gaps that allow the spread of fire from a downstairs flat to an upstairs flat. That means skyscrapers have to be designed conservatively, keeping in mind the tendency of fire to spread upwards. Skyscraper design has to incorporate fire safety measures. It is the duty of the architects to maintain containment, passive fire safety measures. Okay, it's not just about having sprinklers and having fire extinguishers. That's only part of it. The more important part of it is don't provide tracks to fires and don't provide fuel, readily available fuel like wooden flooring to fire, and put plenty of containment like brick walls in the way of fire so that it does not spread horizontally, and put features like chhajas which guide the fire safely away from the house so that fire does not spread vertically. These are some of the features to be kept in mind while designing towers safely. Think about it. Apply your mind. There are no easy solutions. There are no magic bullets. Just plain common sense. And that common sense cannot be replaced by any other form of safety. Now, when this fire does happen, the important thing is that as far as possible, structures should exist in ways that give access to firemen. The fire brigade should get as much access, as much quick access as possible. And that is why mandatory open spaces are extremely important. You cannot have a compromise in mandatory open spaces, because in the event of a fire, if there is lack of mandatory open spaces, fire brigade operations cannot be performed. Fire engines will not have access. They will not be able to come near the building. Rescuers will not be able to operate. Ambulances will not be able to operate. Okay, ladders cannot be applied near walls to evacuate people from refuge areas, and so on. So basically, fire brigade operations become difficult or impossible, and that costs lives. So mandatory open spaces are a must. Similarly, well-designed refuge floors, have to be accessible to people at all times. Well-designed refuge floors are not some kind of a frill. They are not some kind of an optional thing that can be used for party halls. They are critical, and in the event of a fire, the critical nature of these refuge floors, refuge areas becomes immediately apparent. Until then, they seem like some kind of a luxury, just some kind of rules. Nobody needs to worry about them. But that kind of approach to refuge floors is irresponsible. It is a typically Indian mentality, but it is a very irresponsible thing to do. Refuge floors are critical, and they have to be maintained. They have to be built correctly. They have to be accessible. Another critical area is fire safety corridors. People should be able to exit from every floor into the stairwells, and the stairwell, the access to the stairwell has to be clear, should not be an area where fire can encroach. That is why you have to have fire doors which shut there, and you have to, which will keep the access to the staircases smoke free. These are some critical points. If they are not taken care of during building design, they can cause huge amount of fatalities. And if they are taken care of during building design, during structural design, then a very large fire can be averted, and usually that very large fire will not happen at all. It will remain a very small fire. It will remain confined to a flat or two flats. These are some of the features that need to be kept in mind. Reflect on them, think about them, apply your mind. Don't take it easy. Don't do this chalta hai hota hai thing, because life is precious. Good night.